Alright, so welcome to Success Chem 130 revision class. Let's write down the following topics. So that's no matter where we stop, I want you to ensure that you study these topics. Plus, your Chem 130 will look at significant figures and rounding up of numbers. Significant figures and rounding up of numbers. That's chapter 1. Chapter 1 is talking about measurement in chemistry, systems of measurements in chemistry, chapter 1. And in chapter 1, if you check every year of your Chem 130 exam, they are always bringing a question on rounding up of numbers, or how many significant figure is found in a particular number. How many significant figure is found in a particular number, or round up the following numbers. Yes, so rounding up of numbers and significant figures, rounding up of numbers and significant figure. Very key topic for your chemistry. After that, you have chapter 2, now start talking about atoms, molecules, and ions. The students should be proficient in topics like your number of moles, your Avogadro's number, empirical and molecular formula, percentage composition. Class, you can be given a very, very large chemical compound and asked to find the percentage composition of one element in that big compound. You can be given a very large chemical compound and asked to find the percentage composition of one element or one component of that large chemical compound. Class, empirical molecular formula, percentage composition, number of moles, Avogadro's number, isotopy, isotopy, you can be asked to find the average mass between two isotopes. Class, we all know that isotopy occurs when elements have similar atomic they have similar atomic number but different atomic masses. When elements can exist in more than one form. Class, look at chlorine, can exist in more than one form, having the same atomic numbers but different atomic mass. So isotopy has occurred. Now, when isotopy occurs, this is isotopy because all other elements that don't exhibit isotopy, they are known by one atomic mass only. Elements that do not exhibit isotopy are known by just one atomic mass. When an element begins to exhibit more than one atomic mass, class, we're all aware that the numbers on top here are called atomic mass and the numbers below here are called atomic number. Anytime you are given an element and you see a number below, these numbers below represents the atomic number and these numbers above represents atomic mass. These numbers below represent the atomic number and the numbers above represent the atomic mass. So class, when an element can have more than one atomic mass, that element is said to exhibit isotopy. And class, because it has more than one atomic mass, in the exam it could be asked to calculate the average mass. Because when there's more than one mass, it leads to confusion when they're asking us what's the mass of chlorine. Some people say 35, some people say 37, and there's a confusion, which one we go with. So a formula was derived that helps us to determine the average mass of elements that exhibit what? Isotopy. And when we want to determine the average mass, we call the average atomic weight. We consider the relative abundance of each of the isotopes. We call relative what? Each isotope has how much of it is present. It's the relative what? Abundance. And the relative abundance is measured in percentage. Measured in what? Percentage. So there's an abundance of chlorine 35 and there's abundance of chlorine 30. So there are two things used to calculate the average atomic weight. The relative abundance and the atomic mass unit, AMU. Class, we're given the relative abundance of each isotope and the atomic mass unit of each. AMU means what? Atomic mass. Your job is to multiply the relative abundance by the atomic mass unit of this guy plus relative abundance times atomic mass unit of the second guy. Class, if an element exhibits 3 isotopes, you do the same thing for the third person. Relative abundance of the third element times what? AMU of the third element. And then you get the average atomic weight. So anytime they ask a question on isotopy, just know that you bring out this thing. Very, very important. Isotopy is very, very important. Balancing of chemical equation. Class, you're given an equation and you see x, y, z, and you say, find the correct values of x, y, z in the equation. Given the equation xa plus yb to give cf. Class, A, B, and C are the A, B, and F are the components of the equation. A and B are the reactants, F is the product. And they say find the value of X, Y, and C, or Z itself. So what they are simply asking you to do here is to balance the equation. What they are simply asking you to do here is to do what? Balance the equation. What they are simply asking you to do here is to balance the what? Equation. Class, are we following? So class, balancing chemical equation. Class, you learn balancing chemical equation and also everything has to do with reaction stoichiometry. Class, reaction what? Stoichiometry. That means reaction stoichiometry has to do with the what? The mass to mole interactions or the mass to mass interactions between reactant and product. Class. In reaction stoichiometry is when they will tell you that if A and B react to give F, find the mass of F that will produce from 5 grams of A. Calculate the mass of F that will be formed from 5 grams of reaction stoichiometry. And normally when they give you reaction stoichiometry, you must first balance the chemical equation and find out what's the standard what can you obtain from the standard balanced equation before you now ask yourself 5 grams will give this reaction stoichiometry. Reaction what? Stoichiometry. Class. Balancing chemical equation, reaction stoichiometry. Very, very, very important. Class, anything you can listen, I want you to just focus on them for the exam. You write well. I'm promising you that. You just focus on direction. In the exam, you have the direction. Class, of course, limiting reagents, how to determine limiting, and concept of actual and theoretical yield. Actual yield and theoretical actual yield, theoretical yields. Actual yield, theoretical yield. How to determine the actual yield of a chemical reaction, how to determine the theoretical yield of a chemical reaction, and then to can use that to calculate the percentage. Percentage what? Percentage is actual yield A all over theoretical yield T times 100%. Percentage yield is actual yield A all over theoretical yield T times 100%. Percentage yield is actual yield all over theoretical yield times 100%. Give me the percentage yield. Class, the actual yield of a chemical reaction, theoretical yield, all stems from the word called yield. Class, every reaction has what we call yield. So you know to understand actual and theoretical yield, you must first understand yield. Class, the yield is the maximum amount of product that is obtained at the end of a chemical reaction. Follow this. When A and B react to give F, the maximum amount of F formed, the product, yield is about the product, yield is about the what? When two reactants are reacting, we're always going to go and check what is the product formed. Class, the amount of product formed that we obtain after the two reactants have reacted is called yield. It's called what? So yield is the maximum amount of product that can be formed after a chemical reaction has taken place. Yield, maximum amount of product obtained at the end of a chemical reaction. Yield. So that's the definition of what? Yield. But we don't have two types of yield. We have the actual yield and we have the theoretical yield. We have the actual yield and the what? Class, why do we have actual and theoretical? I've explained this before, but I'll come again. The actual yield, class, is the amount of product formed when the reaction is actually carried out. Class, when you mix A plus 10 grams of A plus 10 grams of B, class, not on the board, but actually, that's called actual yield. Now you carried out the experiment. Class, you know that all these reactions right on the board, they are not actually carried out, we're just writing them. It's what, if this and this are by calculation, by theory, this is what we should have, right? By theory. But when someone now goes to go and carry out the experiment, what he got after carrying out the experiment is the actual. But the person that just did his own on the board, if 10 of A plus 10 plus B react, we are going to have 20 grams of F. Class, he did not carry out the experiment. He just did the react. That okay now, if 10 grams of A react to 10 grams of B, but by calculation, we should have 20 grams of F. He never carried out the reaction, class. This 20 grams of F obtained without carrying out the reaction is called theoretical. Theory is theory, no practical, no. But the person that went to the lab and carried out the experiment, he took 10 grams of A, reacted with 10 grams of What he got was not 20, he was getting 18 grams. Class, usually the actual yield is usually lesser than theoretical yield. The actual yield is usually lesser than the what? Please take. The actual yield is always lesser than the theoretical yield. So you will see that the theoretical yield on the board, what they did on the board, is not prone to error. It's not prone to any mistake, right? Because it's easy to just do calculation on the board. Are you recording me? Please stop. Copyright infringement. Copyright what? You don't want to burn data. Stop recording me immediately. Alright, let's move forward. Class. You're in the class already. You should be understanding the energy you used to have recorded. Now, class. 10 grams of A plus 10 grams of B to give us 20 grams of what? C. That 20 grams is called the what? Theory. You are not carrying an experiment. You are not carrying an experiment what? But the one you now went to the lab and mix and you got 18 is actual. Is what? You now say find the percentage yield. You now say actual 18 divided by theoretical times 100 percentage yield. Percentage what? Actual divided by theoretical times what? Sharp. Now, class. Next thing that you should take note of, class. You should be able to write electronic configuration SPDF 1s2, 2s2 in SPDF format 2p6. SPDF configuration of elements. SPDF configuration of what? And class, this question, find the number of proton, neutron, and electron. In, let me give you an example in your past question. That question will come out. That question will do what? Find the oxidation number of chromium in K2Cl2O7. Find the oxidation number of chromium in K2Cl2O. Find the oxidation number of what? Chromium. Find the oxidation number of chromium in K2Cl2O7. Find the oxidation number of chromium in K2Cl2O7. Find the oxidation number of chromium in CrCl4. Class. Chemistry is not good in repeating past questions, so don't expect them to repeat past. Some courses favor past, some courses don't favor past. Professor Charles is too smart for that. Don't expect them to repeat any word for word. If they will do it, it will be one or two. And one telling you, and one that is telling past, and one that is telling you that they will not repeat past. But class, the thing with chemistry is that if you do the past question very well, you will be able to study the language. You will know the language. They cannot repeat the same thing, but they will repeat similar. You understand? In the same line, in the same. Your exam will come in that same line. That's what I mean. But don't just go and cram past question that you just come out like that. But still study, very important. Because if you can solve your past question, you can solve your exam questions. Or it's the same scheme of works. Yes, true. True. Where are you? Class, if they say calculate the number of proton, neutron, and electron for magnesium 2+. Magnesium is 24 atomic mass, 12 atomic numbers. 24 atomic mass, 12 atomic. Find the number of proton, neutron, and class. Proton is 12 because the number below here is based on atomic number, known as number of proton. This is what I mean. This kind of question will come out. Neutron is, how do you get the number of neutron? Atomic mass minus atomic. 24 minus 12. And electron is what? Class, electron, because it's carrying a charge of 2 plus, it's going to be 10. It's going to be what? Class, anytime you have a 2 plus here, you want to get electron. Say 12 minus 2, if there's plus, minus. If there's minus, plus. If there's plus, do what? Minus. And if there's minus? Plus. Class, because this guy is carrying plus 2, the number of electron will be 12 minus. Go opposite to the sign. Go opposite to the... But class, the number of proton is just this number here. Don't do anything. Don't plus or minus. And number of neutron is the one, this minus atomic mass minus atomic number. Atomic mass minus atomic numbers. Number of proton, neutron, and electron. I just saw one exam question now. Yes. Molarity, molar, concentration, class, concentration of solution. Concentration of what? Find the molarity of the solution. Concentration of what? Solution. Concentration, molarity, molarity. Then, molarity is also known as molar concentration. Molar what? Molar concentration. Please, if you are following this video, quickly go to our YouTube page and click the subscribe button. There was a video I posted, we have over 2,000 views, but number of my subscribers are 1,700 or something. It's not so 2,000 people have visited the page, but refuse to just click subscribe. It's not, you're not paying. Some of you just like social media, not go pay, but they debit me. Just click what? Did you link your card to my YouTube channel? No. How would they debit you? Please, just subscribe. You understand? Sometimes when you're working like this, someone says 2,000 views, they think you bought views. Or they don't know whether they buy views or not. About 2,000 views, I saw one video, you understand? But our subscribers are lesser than the people that are viewing the video. So you just come and steal knowledge and run away. Subscribe, this reward of is something, there's nothing bad there. Are we together? You can search for Success Academy TV. If you don't see my face, don't subscribe, it's not me. Are we together? Success Academy what? TV, just search for it on YouTube. Just click subscribe. That's all. It's not painless. It's not paying you at all. Please, if you are here, you may be watching a video, but you forget. You just carry it away. You are learning. I understand. You are learning and you are learning. You will not remember to go and subscribe one thing now. Just click subscribe. When you enter the page, look for the subscribe button. Click what? Please do that for. And let the number of views be commensurate with the what? With this number of subscribers. Another advantage is that if I post any video that can help you, you can say it. Tomorrow, this Chem 130 exam, anything can happen, or if anything comes out, I might help you post it there, you understand? So if you don't subscribe, how will you say? Do you understand? If I see anything for this exam, I want people to write well. If I see anything diamond, I might post it on this channel. And if you have not subscribed, anybody that subscribed, nobody that subscribed, anytime I post a video, you used to get notification, right? It will come up that, okay, so I posted Math 120, shortcut, this one, Math 110. It always comes up. But if you're not subscribed, you will never know when I post something. You will not know until I tell you, or until I send you a link. So please, just show us love, eh? Just click subscribe button. Thank you very much. Thank you very much. Now, how do you get the official number of chromium in K2Cl2O7? Class, K is plus 1. K is what? O is minus 2. O is what? Class, they will give you every other person except the person they ask you to find. They will give you every other person except the person they ask you to find. So they say you should find chromium. They will give you potassium, they will give you oxygen. Class, you're going to equate this to 0 because this K2Cl2O7 is on charge. Is what? But this guy, this second person, Cl4 minus 1. You're going to equate it to minus. Follow me. K2. So K is plus 1, but we have 2. K is occurring twice. That will be plus 1 times. Now Cl2, we don't know Cl, so call it 2C. We don't know who is Cl, we don't know who is. So call it 2Cr. O7, minus 2 times 7. Because each oxygen is minus 2, so minus 2 times 7 minus 14. Equals to what? 0. Why did we equate this, everything here equals to 0? Because this whole compound is on charge. Is what? Is on charge. Plus 1 times 2 is plus 2Cr minus equals Plus 2 minus 14 is what, class? It's minus 12 equals, so 2Cl minus 12 equals 0. Class, when we give us 2Cls, 2Cl therefore will be equal to 3 minus 12 becomes plus. Now divide both sides by. So 12 divided by 2. Class, the observation number of chromium in K2Cl207 is 6. The observation number of chromium in K2Cl207 is what? 6. Class, 3 key topics remaining that will come out. 3 key topics remaining that will come. Class, you can do the same thing for ClCl4. Find the ratio number of chromium in ClCl4 minus. Class, because ClCl4 is carrying a minus 1 charge, you're going to equate whatever you're solving to minus 1. Unlike the first one we did, because this one is not carrying any charge, equate it to what? So when asked to find the oxidation number of an element in a compound, if the compound is on charge, equate your calculation to 0 because the compound is on. But if the compound is charged, equate your solving to the what? To the charge the compound is carrying. To the charge the compound is what? Carrying. Very, very important. Who has done ClCl4 minus? What's the final answer? Huh? Plus 3. Plus. Are we all on the same page? Plus 3, everybody? Plus 3. Some of you, the exam has weakened your voice. When you first resume, there was a danger. When you, like my phone teacher has humbled you, you just, so people always sweat and copying their fear, may I hide this school for the week? Are we together? Please. Just say, cheer up. When the result comes, then you can wear your sweater back. Are we together? When the result comes, class, follow me. Class, gas laws. Let me tell you the aspect of gas laws they like bringing out. Gas laws, the aspect of gas laws they will bring out ideal gas equation. Where you say PV equals to nRT. PV equals to what? nRT. Where P represents pressure, V represents volume, N represents number of moles, R represents gas constant, T represents temperature. The ideal gas equation. Ideal gas what? Yes. Class, ideal gas equation. But class, they might not ask you to find pressure. They might ask you to find the density of an ideal gas. And there's no density in this formula. So that formula is what? Another formula is what? So the density of an ideal gas is pressure times molecular mass all over R gas constant times T temperature. Density of an ideal, pressure times molecular mass all over gas constant times what? Temperature. Let's be fast. Your colleagues want to write the exam here, and they are early, not because they are, some of them, not because they are serious. You know why they are early, right? Why are you coming early to exam? So I can align very. Chairman sit down there. Now you go there. Joe did that. Nkechi come front. Now you did it front. You did it serious. Just wear your glass. They front. If you don't come early, how do you study the environment? Study the what? You want to write the exam? Study the environment. You see my guy Pablo. He came early. Why? So you can study what? Class, follow me. Density of an ideal gas. Pressure times molar mass. If all over gas constant times temperature. Gas constant class, they can confuse you with this. They can confuse you with this. Your gas constant can be 0.0821 atm liter per mole per. Your gas constant R can be 0.0821. I'll tell you when to use this. Or R can be 8.314 joules per mole per Kelvin. 8.314 joules per mole per Kelvin. Your gas constant can be 0.0821 or 8.31 for joules per mole per Kelvin. Class, I'll take top 10 questions, and by God's grace, I'm expecting 70% success. Class, no nice. I want to strategically pick some questions. And now, they might not be repeated exactly, but questions in that line will come out. They are popularly asked questions. They are not, I'm not saying that's the exact question, but if you can solve that question, even if they ask anything on that kind of question, you can solve. If they ask anything on that kind of question, you can do what? You can solve it, you can solve. So I'm not saying that, hey, so don't give us this, but you know, come out. So hey, I didn't say it will come out exactly, but something in that line will do what? But class, let me finish my key points. Quantum number, class, quantum number, class, orbital designations. Orbital what? Quantum number, principal, azimuthal, magnetic and what? Spin. Your principal is N, number of shells, your azimuthal is L, your magnetic is ML, and your spin is MS. Class, we have 4 types of quantum number. Quantum means energy. Quantum means what? Class, the principal quantum number is the shell level. Talking about number of shells. Number of what? Shell. Number of what? Shells. Shells. The azimuthal talks about the orbital designation. Another name for azimuthal quantum number is dash. Class, exam questions. Azimuthal quantum number is also known as dash. It's also known as subsidiary. Subsidiary quantum. Your exam will be subjective, 35 subjective questions. 35 subjective. No options to remind you. No options. So you don't know if you are right or wrong till the result comes out.
Hey.
Okay. Now, class. Azimuthal also called subsidiary. Or angular momentum. Angular what? Class, in the exam, they could ask which quantum number gives the orbital orientation of an atom. Which quantum number gives the orbital orientation? Which quantum number gives the geometry or the shape? It's still azimuthal. I see what? Azimuthal. Azimuthal gives us S, the sharp, spherical shape. P, principal quantum number, the principal shape. We have D, the diffuse, and F, the functional. We have S, P, D, F. S stands for sharp. P is principal, D is diffuse, F is functional. Class. Then we have the magnetic. The magnetic is talking about the block. The what? How the electrons are arranged inside the block. The magnetic quantum number gives us information of how the electrons are arranged inside the what? Block. Class, you do me a favor. All these topics, I cannot teach all of them now. I will touch some things. I will do top 10 topics to random. But class, there's a video on all these topics already. There's a video on all these topics what? I posted the link yesterday. They are on Success General Group. You are not yet on our group chat. Take my number and message me, I'll add you. So I can send you the link to all these videos. Class, even you can be, if you are being honest, it's impossible to cover all your 130 in one day. What we usually do when we come for revision is that when we come, by God's grace, we're able to direct you to where exam will come from. And we have a lot of testimonies in our Math 110 and our physics. It's only our Math 120 that I know that we didn't have any class a day before the exam. And there was no time, it was during the week. And I had the question list, so they now made it more difficult. They now increased the intensity of the... Notice that Math 120 exam started very late. Do you notice? Yeah. It started very... They said, well, that's the question leaked in 1 hour, so they now change everything. And when the lecturer is setting new questions, class, that's the most time the lecturer is very wicked. Because we'll be angry, they are stressing him. You know the stress of going to set new... So that's why they set those demonic questions for you. Are we together? You know, I met a student after the exam, so says, these lecturers don't have fatherly love. They don't have what? Because the questions lack fatherly compassion. The questions lack what? Wicked integration. Integration from the pit of hell. Integration from the what? So class, there are videos on all these topics already. So I will send you the link. So says I'm on your group chat. Send me your number. This is my phone. I'll send it. They go and sit down and watch them. Someone says, I was seeing that one comment on the YouTube video. Sir, the videos that these videos, can you show there is 1 gig? Class, 1 gig or 1 F? Which one do you prefer? 1 gig or 1 F? Say success, it's too long. I use 1 gig to watch this video. How much is 1 gig? Do you know what you spend if you fail a course? How much is 1 gig, class? 500. Come on, take the 500. It's not to fail the course. I'm joking. I said, come and take. And someone says, sir, someone said they're arranging the shirts, sir. We together. Class, go and buy 1,000, get your A in the course. If they say bring 1,000 and make A, you say no. 1 gig is too much. So don't look at your data. This is your exam. You're not watching TikTok. Do you know how much you have spent on TikTok in this life so far? And Instagram and Facebook. Now, something that will help you for your exam, you pay school fees. You say no, 1 gig, you're not complaining. When they are playing Sabinus for you don't remember gig. When they are playing chemistry, sir, can you shorten the videos? I will shorten your result. I'm joking. But class, so please, don't look at the data, pass your... I carefully taught these topics very, very well. And I'm supposed to even charge you for the videos. I'm giving you free. So the least complaint should be about gig. Should be about what? Gig. Watch it and learn and study. Class, if you want those videos from beginning to the end and you don't write 20 and 130, it's not possible. It's not possible. It's not what? Please settle down. What balancing of chemical equation by algebra. If I teach that one only today, time will not even be enough. But I have to touch everything. Now, class, I'm going to teach you how to balance. So please go and watch quantum number. There's a very good video of quantum. Sit down, watch it very well to come out. Something must come. Find the maximum number of electrons. I will remind you of the things I'm saying. Find the maximum number of what? Class, formula for maximum number of electrons is 2n squared. Formula for maximum number of electrons is what? 2n squared. 2n, where n represents number of shell. Where n represents what? Formula for maximum number of electrons in an atom, in an orbital, or is what? 2n squared. Where n represents number of what? Shell. Class, in that video, I explained when sometimes you might not use number of shell, right? I taught it in the class. Sometimes you might not use this n to calculate number of electrons. Please watch that video, please. I'm begging you, watch that. If it means using someone's hotspot, or I think they give free Wi-Fi and ICTC. You paid your school fees, right? Shape. Some students come and sit down outside ICTC and they're pressing their phones. They're enjoying their school fees. I think still doing that thing, right? So you can come and sit at ICTC in this night. Bring your phone. Are we together? Stay outside ICTC and be watching the what? Be watching the what? If anybody asks what are you doing, they say I'm using my school fees. Are we together, class? Now Lewis structure. Lewis. Class, draw the Lewis structure and resonance structure will come out. Draw the what? Then class, bond order. Class, they will ask you to find the bond order of someone. Bond. Class, this video is on the channel. Go and watch it. Go and watch. Bond order and bond polarity. There's a video on it there. In fact, I said I will send you all the links, right, class? Sit down. When the exam is like 2 p.m. tomorrow, right? 2 p.m. Thank God it's not morning paper, so you have from now when we finish this class till 2 p.m. Say what? Sit down and watch it. Post all your Facebook, post all your Instagram, post all your TikTok. Sit down, watch it and cut it, class. Anyone I pick and I start teaching it now, I'll be wasting your time because you'll be faster at your own pace. When you're able to watch it at their own pace, it'll be what? You'll be faster. But class, significant figure. If they say, let me check your knowledge of significant figure. Generally, 0.0281 has how many significant figures? 3. 3? Is it 3 or 4? 3 or 4, class? 3. Raise up your hand. 3, raise up your hand. 4, raise up your hand. You don't know how he's doing you. Raise up your hand. Because you have not raised up your hand for anyone. You don't know how he's doing. Class, you are all wrong. You are all. Any number without a measurement unit is not. Any number without a measurement unit is not. Who remembers that first time I taught you that time? Beginning of the semester. It now looks like it's 3 years ago. When did you do this? It was not January or December. Any number without a measurement unit has 0 significance. Class, anytime you give you a number, there's no units, class. It is not In science, if you don't have a unit, we cannot recognize you. Because every quantity has a... We can't recognize you in science without a unit. Class, please take note. As simple as numerical figure, someone has missed this question already. It's simple, you don't still miss out. As an empirical formula is simple. If I give you a question on empirical formula, you fail it. Go and study their videos on class. Look at this, write up this number. 0.001. For class, you actually correct is 3 significant. 281 are significant. These 2 zeros are not what? You know we have 3 types of zeros, I taught them, right? So we have trailing zeros, we have trap zeros, and we have leading zeros. We have 3 types of zeros. Trailing zeros, trap zeros, leading zeros. Class, any zero that comes before a non-zero digit is not. Any zero that comes before a non-zero digit is not what? Class, how many significant figure does 2000 have? 4? You are 4 for the trap again. Does he have a unit, class? You are constantly falling. You are constantly what? Falling. Does he have a unit, class? So why are you saying 4? Even your 4 is still wrong. You unit or no unit, class. 2000 has only one significant figure, which is 2. Class, anytime you have a whole number, anytime you have a whole, and these zeros, the zeros that come before you after a non-zero digit are not significant in the whole number. But class, follow me. If you have 2.000, these 3 zeros are significant in the decimal because it comes after the decimal point and after the non-zero digits. Class, for a decimal, zeros after a non-zero digit are significant. For a decimal, zeros after a non-zero digit are significant for a what? But zeros after a non-zero digit for a whole number are not. So class, 2000 has only one significant figure. If there's a unit, if there's no unit, 2 of them are 0, 0. 2000 Newton has only one significant. But class, look at this same 2000. Class, this is not time to write. Drop your notes. Where's your math 120? Bring it out. 2000, you put 5 here, class. Class, this 5 automatically makes all these zeros significant. 2005 has how many significant figure now? 5 significant for everybody today. The only time a zero is significant in a whole number is if it is trapped between 2 non-zero. If it is trapped between 2 non-zero, if you don't have past question, tell parents to collect this after the class. Come and collect this one, eh? If you don't have past question, I'm giving it free. I'm not selling it. You don't have past, come and collect after the. Come and collect this one. Now, class. Anytime a zero is trapped between 2 non-zero digits, it becomes what? Significant. Class. 050 joules. As how many significant figures? Think well. You know I'm good at confusing you. So right? 1, right? I love those that are saying 1. Well done. You're doing very. 1, right? It's 2, right? Class. 1 is correct. 1 is what? Someone said 3. I shall wait this one to confuse you more. Class, these 2 zeros are not what? Class, zeros that are just strolling around and they are not protected by a non-zero digit. They are not. These 2 zeros don't have any cover. They're just there. But I mean this was 505. This zero has this 5 and 5 covering. So it made this zero what? Class, follow me. Place. If you are here, this first semester, let's tell ourselves the truth, eh? Any student that can avoid F, try. Any student that avoids what? Try. If you can avoid F, you try. Because class, they were not fair on you, let's be honest. If anybody that got C in this semester is like A in normal semester. This semester is not normal. It's not what? C in this semester is like A in other. If you can get C, you really try. You really what? Class, you can balance your CGPA second semester. This first semester, they rushed you. Some people were still doing clearance and they're writing exam. Some of you use your reg number to write exam, am I correct? Yes. This is the first time in history of Unipod that we're using reg number to write exam. Ask your senior colleagues. They're outside, this is the 9th student. I taught them in 100 level 2. This is the first time we're using reg number to write exam, year 1 exam. That's never. So this set is an extraordinary set. So class, One semester will not define your whole result. But class, you can balance it with your second. You know when they calculate your year one CGPA, they cannot use only your first semester. Year one member of first and second. Any course you didn't do well first semester, you can balance with second semester. And when they do your cumulative, you still balance. Class, you got C in your chemistry first semester, they will still be chemistry second semester. If you beat it A, you balance the C class and bring you up and bring you what? Someone came out with first class doesn't mean he never got C. You can get 1 C and you still come out first class. You can get even 2 C, you still come out second class upper. Someone did very well, came out with 2 1, doesn't mean he never got a deal. But you know how to balance it. They don't call CGPA, cumulative grade point. I want to advise you, this first semester now, I'm not expecting a very good result from generally. I'm not talking about you, I'm not praying, wishing you bad. But within what I saw, class. And class, even if they say everybody sorts, they cannot pass everybody. If everybody pass, school will still, there will still be a problem. They will reject the result. After a lecturer's mark, Senate has to approve the result. Do you know that? Yeah. Senate has to do what? The result will look, they will reject the result. So second semester, I want to advise you, start early. Start what? And you have a lot of balancing to do, balancing work to. Some of you resume late. I met one guy say, sorry, I didn't even know about your tutorial. I didn't know about that is anything called tutorial. I resumed late, I was not doing my clearance. So if this is the first time of seeing me, if you're here, this is the first time of seeing me, you just met me today. Are you saying just like that in class? Don't I come to you all every day? But because when the school resumed late, everything was very scattered this semester. One girl was saying, I didn't know about your class. I didn't even know. So class, second semester, set yourself, say, okay, this first semester, let it. I will balance second, start early. Start what? If I want this school is after exam and you finish your break, you have 2-3 weeks break. Start a serious class in all your second semester courses to cover for you very, very well. Now follow me. Class, Lewis structure. Lewis. Draw the Lewis structure of, right down. Draw the Lewis structure of NO3 minus, SO3 2 minus, CH3OH. Draw the Lewis HCN H2SO4. Draw the Lewis structure. Only this one, please, after writing this down, just like the Israelites moved from Success Math 120 class, the struggle is real. The struggle is real. You can see your colleagues. Migration of the 100 level students for preparatory class math, Chem 130. Some are seated, some are still moving. Moving like the transfer of electrons from one shell to another. Since we are dealing with chemistry, let's use chemistry terms. Movement of the ions. Transfer of charges. Class, chemistry exam revision, welcome back. We have to do a little migration, but we are back. Chem 130, revision. Class, we have to draw Lewis structure. Lewis structure is a very, very key aspect of this course. Lewis. When you have to draw Lewis structure, class, very, very simple. You just need to follow the procedures. You determine the number of valence electron, determine the central atom. Class, step 1, write down how to balance, how to draw Lewis structure quickly. Because it's a good exam topic. Lewis structure is a very good exam. How to balance Lewis structure. Sorry, how to draw Lewis structure. How to draw Lewis. I'll give you a simple step-by-step approach. We also have the formula method of drawing Lewis structure. We have formula method also, but I prefer the step-by-step because it can demystify any. Please make sure you go and watch that video on bond order. It's not something I can teach here, it's long. Because you will have to do with bonding of orbital, anti-bonding orbital. Yes, bond polarity, bond order. Go and watch that video, especially bond order. Bond polarity. They can give you 3 compounds. And each of them is more polar. Arrange in order of increasing polarity, PCl. SCl and CCl. Class, in increasing polarity, that's from the least polar to the most. Class, what makes bonds polar? The distance or the difference in the electronegativity between the two components that makes the bond. Class, phosphorus is what group in the periodic table? Phosphorus is in what group in the periodic table, class? Phosphorus in group 5. Class, let me tell you the easiest way to know the group an element belongs to. Class, what is the number of phosphorus? 15, right? What is the electron configuration for phosphorus? 28. Class, the last electron on the number of valence electron of an atom tells us the word group number. Phosphorus in group 5. Group what? If you ask what is the group does sodium belong to, sodium is in group 1. Sodium is 281, 11. Number 1. The last electron in the shell tells me the group number the element belongs to. Because the number of valence electron is equivalent to the number of what? Group number the element belongs to. Sodium belongs to group 1 because of 1 valence. Phosphorus is in group 5, class. What group does sulfur belong to? It's group 6. Group what? So sulfur is group 6. What group does carbon belong to? Is group 4. Carbon is 2,4 because first 20 elements: hydrogen, helium, lithium, boron, beryllium, carbon. So hydrogen, helium, lithium, beryllium, carbon. How am I saying? So carbon is number 6. Carbon is number what? 6. I'm rushing. Carbon is number 6. So if you are writing the electron configuration, you have 2. This 4 is what we're interested in, the number of valence. So carbon is in group 4, class. See, we're going to use the groups to determine polarity, class. Because some people don't know what to do. They ask, I read this compounds in order of increasing polarity, bond polarity, bond polarity. I've taught it in the digital video. I'll send you the link. Just message me. Let me draw the number again in case it's not correct in the other. We don't like that board. You can collect it on this board. So says, message me year 1, please. Can I join? Can I get the link? Those videos, please let me study them. Class, this is group 4. I mean that group 4 comes before group 5, right? Yeah. So 4, 5, 6. See, the arranging element is group 4, 5. Chlorine is in what group? 7. Because chlorine is what? 2, 8, 7. 17. Class, this carbon, this phosphorus, this sulfur, this chlorine. Notice that all of them are bonded to chlorine. Phosphorus bonded to chlorine. Sulfur bonded to chlorine. Carbon bonded to chlorine. Want to check who is more polar? Who is more what? Class, the person that is farther away from chlorine is more polar. The more far the compound is from the person is bonding with, the more polarity, the more what? Polarity. Class, so who is more polar between CCl, SCl, and PCl? Tell me now. Who is more polar? CC. Why is CCl more polar? Class, carbon is there's a greater distance between carbon and what? Chlorine. There's a bigger distance in the electronegativity between carbon and chlorine. So class, CCl is the most polar bond among these 3 bonds. Followed by who, class? Followed by talk, class. Have you collected your voice? Talk.
PCl.
PC. Followed by SC. So the person with the lowest polarity is what? I almost said solarity. Polar SC. So if you are arranging them in order of increasing polarity, from the lowest polarity to the highest, what are we going to have? SCl less than PC less than CC. This is the correct arrangement. I say arrange the following bonds in order of increasing polar. But class, notice that all these 3 are. What kind of bond exists between them? It's covalent bond. Covalent what? Class, it's covalent bond that exists between 2 non-metals. Check, phosphorus and chlorine are non-metals. So you understand why I'm rushing, right? I'm talking fast, but it's understandable, right? Exam is just behind us like, this is not how I teach normally, but I'm rushing. Too many topics, something the other time I had us teach it. See, I've left. What is the lecture I'm supposed to draw? I enter here. These are exams. Exam don't pushes you every. So class, bond polarities. But the 2 have entered bond. The type of bond between them is covalent. Another name for covalent bond is called what? I've taught it in this class. We say dating bond. I will date you out. Class, it's called molecular bond. Molecular what? Dating bond is a type of covalent bond, class. It's not another name for covalent bond. In covalent bond, we have the normal covalent bond and we have the coordinate covalent bond, also called the dative. Class, we have the normal covalent bond and we have the what? Coordinate, also called the what? Dative bond. So that's another name for covalent bond is molecular bond. What is covalent bond? It's the bond between two non. But class, let me tell you. I don't mean there's a fourth person here, like sodium NaCl. Class, note that they say you should calculate bond polarity. Note that the bond between a metal and a non-metal is more polar than any bond between any two non-metals. The bond between a metal and a non is more polar than any bond between any two non. So class, among these four, don't even look at where the Na is on the table. Don't even look at where Na is on the table. Sodium is a metal, right? Chlorine is a non-metal. As soon as you see a metal and a non-metal, it has the highest polarity, class, because it's an ionic bond, also an electrovalent bond. Plus, anytime a metal and a non-metal form a bond, their bond is more polar than between two non-metals. But anytime you are looking at the two non-metals, just check difference in electronegativity. Where this will come in now, if they say, well, who is more polar between NaCl, MgCl2, and AlCl3? Who is more polar between them? It's still NaCl, right? Someone is thinking, can I know your reason? God bless you. It's far from chlorine, right? Na is in group 1. Na is in what? Magnesium is in group. Aluminum is in group. So you have Na, magnesium, aluminum. As you're getting closer, where is chlorine? Group 7. So who is closer to chlorine?
Aluminum.
So it will be less polar, right? So sodium with chlorine will be more polar. Because this is now between sodium and chlorine, magnesium and aluminum and. So if you ask to arrange them, who is more polar? NaCl is more polar, right? Followed by who is more polar after NaCl? Followed by Al. So if they ever bring any question on polarity, give it back to sender. Back to what?
Sender.
Another for covalent bond is molecular. Class. Comrades. Well done, well done, well done. You have successfully entered my video. I featured the success featuring. What's your name? Class. Now, let me structure. Step 1, determine total number of valence electrons. Write down. Step 1, determine total number of valence electrons. Step 1, determine total number of valence electrons. How to draw Lewis structure. If you are my student and you have the notes already, you don't need to be writing it down. Except you have thrown away your notes. Step 1, determine total number of valence electron. Step 1, determine total number of valence electron. Step 1, determine total number of what? Step 2, determine the central atom. Step 2, determine the central. Step 2, determine the central atom. Step 2, determine the what? Step 2, determine the central atom. Note, central atom is usually the least electronegative atom or the least occurring atom. The central atom is usually the least electronegative atom or the least occurring atom. Central atom is usually the least what? Electronegative atom or the least occurring atom. Class, if you ask your lecture of H2SO4, the person that will be the central atom is the person that's occurring the least. Hydrogen is occurring twice, oxygen is occurring 4 times, sulfur is occurring. The person occurring the least becomes the central. Also note that hydrogen can never be your central atom. Hydrogen can never be your central. Hydrogen can never be the central what? Step 3, are you there? Use bonds to link the central atom to the other atoms. Use what? Bonds to link the central atom to the other atoms. Use what? Bonds to link the central atom to the what? Other atoms. Use bonds to link the central atom to the other atoms. Note, each bond used takes up 2 what? Electrons. Each bond used takes up 2 electrons. Note, each bond used takes up 2 electrons. Each bond used takes up 2 electrons. Each bond used takes up what? Last step, use the remaining valence electron to balance the Lewis structure. Use the remaining valence electron to balance the Lewis structure. Use the remaining valence electrons to do what? Balance the Lewis structure. lecturer came with police with exam questions. You go hot today. Oh. you don't use police to bring any of your questions. Science. I mean, this course go hot. Engineering. I think they're in year 4, year 3. Police carry exam. Don't be dumb. Class, follow me. Let us join the lecture of A2SO4. Step 1, determine total valence electron. Total number of valence. How do you determine the number of valence electron? List all the atoms in the compound. H, we have 2H. S, and 4 oxygens. O4, right? 4. Class, there are 2 types of electrons. We have inner core electrons and we have valence. The valence electron is the electron on the last shell of the atom of the element. The last shell is called the valence. So, like, look at hydrogen. Hydrogen has 1 valence electron, but we have 2 hydrogens, so 1 times 2. Class, another name for valence electron is the group that the element belongs in the periodic table. I think I've showed you sulfur here. Sulfur has 6 valence electrons, because sulfur and oxygen belong to the same group. And the family of group 6 are also called chalcogens. Periodic table, group 6 elements are called chalco. You examine the subject, you know I'm giving you key points. That's how they will ask it. Which of these is the correct name for group 6 elements in the periodic table? Dash. You will not know whether they are wrong or right because there's no options. Chalcogens, they are called what? We know that group 7 are called halogens, right? Group 7 elements are called halo in the periodic table. All elements in group 7 are called halogens because they are salt formers. They are called salt. Group 7 elements are salt formers. This is a revision class, so it points enter, I teach it. This is not like normal class where you are teaching chapter 1, chapter 2. Anything that enter will say it for exam. Halogen, salt. Group 6 are called chalcogens. You just need to get 35 questions correct. So it's not about topics now. If they bring it out, you can pick it. You are done. Class. Group 1 are called what? Alkali metals, right? Alkali. Group 2 are called what? Alkali earth metals. Well done. Alkali earth metals. So we said that this covalent bond is so-called molecular bond, right? And there's a type of covalent bond that's called coordinate covalent, also known as delta bond, also known as what? Also known as another name for coordinate covalent. I know I'm giving you this point. This is the way you teach subjective exam is from OBJ. This point, subjective is your point. Just put the correct answer there. Which of flow is known, also known as coordinate covalent bond, delta bond? You got it in your mark, no stress. Subjective exam is just points. Nobody wants to see your solving, just get the correct answer. Now, what's the difference between covalent bond and coordinate covalent bonds? In covalent bond class, the sharing of electrons between 2 atoms. And class, the 2 atoms that are sharing the electrons bring electrons for sharing, they bring electrons for. But in coordinate covalent class, only one person is bringing an electron for sharing. In coordinate covalent bond, only one atom is bringing an electron for what? But in covalent bond, the 2 atoms are bringing electrons for sharing. If you look at oxygen, O2. The bond between the 2 atoms of oxygen to form O2 is called covalent bond. The bond between the 2 atoms of oxygen to form what? Is what? Because class, one oxygen atom is 2, 6. Another oxygen atom is 2. That is electronic configuration. Electronic what? Of this oxygen is 2 on the K shell, 6 on the L. 2 on the K shell, 6 on the L. Class, each of these oxygen is looking for 2 more electrons to obtain an octet state, to obtain a what? So, none of them has the 2 electrons. So what they will do is they will bring the electrons for sharing. Let the 2 be inside 2, then 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Class, this oxygen will say, let me bring out this my 2 electrons out. And this also brings out 2 electrons what? And they will share together. And by sharing the electrons, so this person brought 2, this person brought this covalent or molecular bond. It always happens between 2 non-metals. The type of bond that exists between 2 non-metals is covalent. But the type of bond that exists between 2 non-metals, this coordinate covalent is also between 2 non-metals. So these 2 are non-metals, what are the one that exists between a metal and non-metal? Electrovalent or ionic bond, right? A metal and a non-metal is electrovalent or ionic, like NaCl. Sodium is metal, chlorine is non. This electrovalent or ionic bond, electrovalent or ionic. But between 2 non-metals, either covalent or coordinate covalent. What's the difference? There are 2 non-metals, but here they sharing of electrons, class. In coordinate covalent and covalent, there's sharing of what? But in electrovalent, there's no sharing of electron, there's transfer. Class, there's transfer of electron from the metal to the non. But class, in coordinate covalent and covalent, they're sharing, they don't transfer, they share. Now in covalent, the two people are involved in the sharing, two of them bring electron, let us share. But in coordinate covalent, only one person is bringing electron for. In coordinate covalent or dative bond, only one person is bringing the electron for what?
Sharing.
A good example of coordinate covalent bond is the one that happens between ammonia and H plus ion. Na3 and what? Class, anytime you are positive in chemistry, means you have lost electrons. So this H plus means that what? This hydrogen has no electron. No what? Because normally hydrogen usually has just one electron. And H plus signifies that even that one electron has been lost. Usually hydrogen has only one. But H plus means that even that one electron has been what? When you are positive, you have lost. When you are negative, you have. In chemistry, when you are positive, you have lost. When you are negative, you have. So plus one means that this hydrogen has even lost one electron. So he has no electron. So it's coming to this NH3 to come and share. This NH3 will provide you with 2 electrons that will fill up his shell. So this NH3 bond is the one providing you with 2 electrons. Class, N is what? 2, 5. Because nitrogen is number 7. Number. This is the shell structure, atomic structure for nitrogen. For what? 2 in the K shell, 5 in the L. Now, nitrogen is carrying 3 hydrogens, right? It's carrying what? Each hydrogen has one electron already. Each normal hydrogen has one. These are the 3 hydrogens. Now I'm talking about this one here too. So each hydrogen is just one more electron to be stable, right? So it will bring his own 1 electron and come and join with this, and they will share. So these first 3 hydrogens, they are bringing something to the table. They are bringing something to the what? H. But this other hydrogen say on the table, and the what? He's not bringing anything. He's not bringing what? But it's coming to collect 2 electrons. So this person is not bringing anything. He's collecting these 2 electrons. And you say what? Dative bonding. And we have NH4 plus. When NH3 reacts H plus, we have NH4 dative bond. Now let's go apply the Lewis structure. Let's apply the what? So the determine total number of valence electron. Hydrogen is, we want to draw structure of H2SO4, one structure of H2SO. H is 2. Sulfur is 6. Oxygen is 6 too. But 6 times 4, 24. So this is how you determine total number of valence electron. Find the number of electron in each atom of the compound you want to draw the Lewis structure. Find the number of electron in each atom, not just number of electron, number of valence. Classes, it's valence electron we use to draw Lewis structure. We don't use normal electron. We use valence. We use valence electron. What will be the total class? 2 plus 6, 8 plus 24, 32. Class, I didn't mean H2SO4 was carrying a charge. They say draw the Lewis structure of H2SO4 2 minus. Follow me. Adding H2SO4 was carrying a charge. After finding total number of valence electrons, we're going to add plus 2. Plus what? If the charge is minus, add. If the charge is plus, subtract. Follow me. After finding total number of valence electrons with the atoms that it contains, right? If it's carrying a charge, you're not done. If the charge is negative, add the charge. If the charge is positive, subtract the. But if there's no charge, continue like that. Now, class, we have obeyed step 1. Total number of valence. Step 2, determine the central atom. Class, central atom is person is occurring least. Sulfur is obviously the central because it's occurring just once, class. And we just told you that hydrogen can never be in the center. Hydrogen can never be your central. Now use bonds to join the central atom to the other. Class, anytime there's hydrogen and there's oxygen and the other class, put join hydrogen last. Join hydrogen what? So I'll first join these 4 oxygens. 1, 2, 3. Is it up to 2?
To 2.
What's time exactly? Huh?
147.
1, 2, 3. Class, this sulfur, you cannot join. We still have hydrogen to join to the central atom, right? We cannot join these 2 hydrogen central atom because class, each bond represents 2 And every atom cannot take more than 8 electrons. You can't take more than what? So class, you cannot put more than 4 bonds around sulfur. So there's no way you can bring in hydrogen like this. This what? Wrong. This what? Hydrogen will have to come and be joined with at least any of the 2 oxygens. Any of the 2 what?
Oxygen.
Class, by how many bonds have we used? 1, 2, 3, 4, 5,
6.
Did we say each bond takes 2 electrons?
Yeah.
So 6 times 2.
12.
So by using 6 bonds, we have used 12
1.
electrons. We have used 12.
Electron.
So how many total of electrons do we have? 22 minus 12. Only 20 electrons are left, class. Class. These remaining 20 electrons we're going to use to balance the Lewis structure. The full name of this structure is called Lewis dot structure. Lewis dot. If we're going to be using dots, this remaining 20, we're going to use dots. We're going to use what? Class. How do we balance, class? Every atom in the Lewis structure must have 8 electrons around it. Either true bonds or true dots. Must have 8 electrons around, except hydrogen, which must have 2 electrons. Hydrogen needs not 2 electrons to be stable. Hydrogen needs just 2 electrons to be what? So it means that these 2 hydrogens are stable. By giving a bond to hydrogen, hydrogen is okay. Just give 1 bond to hydrogen, hydrogen is what? Just give 1 bond to hydrogen is okay, class. So our 2 hydrogens are satisfied. Our sulfur is okay, because it has 4 bonds around it. And each bond is giving him 2 times 4.
Yes.
So what they put are not okay. This oxygen is not okay. How many electrons are around this oxygen now? 4. Why? These 2 electrons, this bond is giving him 2 electrons. Another 2 electrons, 2 plus 2. How many more does he need to make 8?
4.
1, 2, 3. You put 4 electrons. Class, where are you getting the 4 electrons from?
20.
20 minus 4.
16.
Who said 8? You need 40. I'm really trying on this student too. Now, this guy, how many electrons does he have? 2 plus 2.
4.
How many does he need to make 8?
4.
Where are you getting the 4 from? 16 minus 4.
12.
12 is remaining, right? This oxygen, how many electrons does oxygen have now?
2.
Because this bond is giving him 2. How many does he need to make 8?
6.
1, 2, 3, 4, 5. 12 minus 6.
6.
How many does he have now?
2. 2.
How many does he need to make 8?
6.
1, 2, 3, 4, 5.
6.
6 minus 6.
0.
When you know you have finished joining your structure is that you have used up all your valence. And every atom in your structure, it has 8 electrons around them, except hydrogen that is not 2
Electrons.
Notice I would not put any dot around hydrogen because 1 bond has given him 2 electrons already. And this is the electron of H2S, so class, I didn't mean electron was carrying a charge. I didn't mean this test was carrying 2 minus. You now bracket everything and put 2 minus outside. So anytime they have to draw literature of a compound that carries charge, bracket and put 2 minus. Class, are we together? Are we together, class? Class, what you do for me? You have to go and watch that video. I have an exam, I just remembered. So you have to go and watch those videos. Message me, I'll send you the links. Sit down, watch them. I've taught all these things already. I've taught all these things what? Already. I've taught all these things. If you watch that video from beginning to the end, you will pick enough exam key points. Exam what? Exam key points. So class, put in your best. This is our last tutorial for the semester. Next time we'll meet the second semester, and I'm going to make sure I start very early. Before any of your practicals even start, I want to round up 60-70% of your courses. I don't want us to rush this thing, like it's not good. It's not what? But what we're going to for the second semester is organic chemistry, wicked structures, skeletal structures, chemical kinetics, magnetism, a solenoid, Balsabat's law. That's what we're waiting for the second phase 1, 2. You have 2 phase second semester. So as soon as you finish your exam, you will go on your break, of course. But we'll start the semester very early. I will resume my tutorials because first semester, we have to balance it. We have to do what? Class, I wish you guys the best. Can we say a short prayer for your exam? Can we say a short prayer?